All right, some of the things we're going to do in section 6 and 7 are going to require us to be able to do some factoring. So just a very quick review in terms of factoring. Number one, I always talk about 3 steps. 1, 2, 3. And I talk about 1, 2, 3 in terms of prefixes, monomial, binomial, trinomial. So number one, what we're actually looking for is a common monomial that we can factor out, or as a lot of times we've talked about, is a greatest common factor. So what we look at in our polynomial is what's the biggest number piece that I can divide out of every one of these. And so what we look at is we see that, hey, I can take a 3 out of all of these. The second thing we look at is, do I have common variables? And if we do have common variables, such as if I had 4x to the third plus 7x squared, if I did have that common variable, what we want to do is always take out the smallest exponent. So in this case, my smaller exponent is the second, so we're going to divide out a x squared. What we're in fact doing here is we're going to reverse the multiplication process of polynomials. We're going to reverse, in this case, distribution. So I'm taking this 3 out, so that 3 ends up outside the parentheses. So the 3 divided by 3 is going to go to 1. Okay, the 9 divided by 3 is 3. 15 divided by 3, 81 divided by 3. Over here, we're dividing the x squared out of each of them, so that's the piece that's on the outside that before we had distributed through the parentheses. And so we're left with a 4x and a plus 7. Step number 2, or binomial. Binomial, the big one that we look for is a difference, which again is subtraction, of perfect squares. Okay, can I write the 2 pieces as something squared? And it comes out to be this pattern, a squared minus b squared is going to be equal to a minus ba plus b. Or again, what these are conjugates of each other. The only difference in my conjugates, again, is that the sign between them is one time addition, one time subtraction. So what I do in this example is I look at my 4x squared, and I see that I can write the 4 as 2 squared, and then the x squared is x squared. And then I can write the 9 as 3 squared. So these become my a and b. The 2x is my a, the 3 is my b, and so we get 2x minus 3, 2x plus 3. A very common situation you'll run into. A couple other patterns that you'll see with binomials is the sum of cubes and the difference of cubes. Not common, but it's good to have these written down in your notes. So if you do ever run into a binomial where they're cubes instead of squares. Okay, so for instance, I may have something like x to the third minus, well actually let's go plus here, 8. And what I look at is that I can write that as x cubed plus my 2 cubed. And so then in this situation, my x is my a piece and the 2 is my b piece. And we just fill in where we see it. These signs always stay the same. This will always be a plus, this will always be a minus, this will always be a plus, even if I'm dealing with a negative value. Okay, so a is my x, plus my b is 2, my a, which is x squared, minus the a times b, so x times 2 or 2x, and then plus my b squared. Now the one thing you notice is that we had a difference of squares, and now we have a sum and difference of cubes. The sum of squares is not factorable. Okay, so if you encounter something like a squared plus b squared, you can't do anything with that. All right, so step 3 then becomes try. Okay. Now, when we talk about tries, we're talking specifically about quadratics. Okay. So something in the form ax squared plus bx plus c. Okay, we're not talking about other trinomials or any just random trinomials. They need to be these quadratic trinomials. And the first thing we'll look at is what happens when a is 1. Okay. Now, I always talk about you need 2 numbers, which I'll call m and n, that are going to do 2 things. One, they're going to multiply to my value for c, which includes the sign, and at the same time add to my value of b. Okay. And I think what we should be able to do at this level is come up with those values and just go to my two binomials that I'm going to get as my solutions. Okay, and so what I'll talk about is look at the ways that I can multiply to 16. Always start with 1 times the number itself and work your way up. 2 times 8. 3 doesn't work. 4 times 4. And now I'm back going up, so I'm not going to go anymore. Multiply to a negative. One of them needs to be negative. Add to 6. Here's my two numbers. Once I find those two numbers again, I'm just simply going to put one with my variable and then the other one with my variable. And what I'm doing again is I'm reversing that multiplication idea. And what I'm actually doing is reversing the FOIL situation. If you kind of think about FOIL, the outside piece and the inside piece get combined more times than not. Okay. So what I have here then is x minus 2, x plus 8. Okay. Now there is the box method that you learned one of the last couple of years. It's really the same thing. Again, the box idea is in the top left, you put your quadratic piece. Bottom right, you put your constant piece. But now what goes in the other two boxes are exactly those two numbers we just found. The minus 2 with an x and then the 8 with an x. Okay. And so once you find those numbers, it's easier just to put them into the binomial. And then you're done. To follow up with this, and we'll see this again, is now how I do this is I look for what can I factor out of the top row, what can I factor out of the bottom row. There's my x plus 8. What can I factor out of the first column? What can I factor out of the second column? And since the top one's negative, we're going to take the negative as well. And there's your other factor. All right, now the most difficult piece when factoring is usually when a is not 1. Okay, and I got 3 quick methods to go through. Number 1, we can do the same situation that we kind of just got done with. We need two numbers, okay, that are going to, in this case, multiply to what I get when I take a times c. Okay, so 1 times 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work. Now I'm recycling. It's negative, so one of them needs to be negative. Same time, they need to add to 5. Well, the closest I get here is this is negative 5. If I just switch my signs, now it becomes positive 5. So now what I'm going to do is I'm going to go in and I'm going to substitute those values in for that 5x. Like I said earlier, what we're going to be doing here is I'm reversing the multiplication idea. And so this is where we see that FOIL piece really coming into play, because I went from 4 pieces, and then what I did again was I combined these two to get to the 5x. And so we are truly reversing it all. All right, then what we're going to do is it's called factoring by grouping. I'm going to put some groups together, and generally what will work is if I put the first two together, second two together, and look for a common factor that I can pull out of each one of those. So we're back to actually that step number 1, we're looking at GCF. So out of these two, I can take out a 3, and I can take out an x, and when I take those out, I'm left with a 2x. Okay, and when I divide that 3x out of here, it doesn't cancel again, it multiplies out to 1. You'll always be able to take an x piece out of the first one. The second one, I'm going to be able to take out a 4, which same idea, I'm never going to be able to take an x out of that one, and I'm left with 2x minus 1. Nice thing about this little process, if it's going to work out, okay, we should have a common factor, or these pieces in the parentheses should be the same, because that's going to be one of my factors. And then this leftover junk becomes my other factor. So another way we could do this, like we said, is with the box. And with the box, again, what happens is your quadratic top left, constant bottom right. Now, we're going to go back and do the same process that we did here, looking for those two numbers. Okay, and again, what we found those to be was 8x and a minus 3x. In kind of a similar fashion, now what we're doing is we're taking that greatest common factor out here, which is 2x. Leader's negative, so we take that out. There's nothing common, so I got to take out at least a 1. There's one of my factors, 2x minus 1. When I do the columns, I can take a 3 and an x. I can take a 4. Same thing I got in the previous problem. Okay. So that's another method you could use, is the box. Now, this is probably a method that I wouldn't suggest. Hopefully you're able to factor. There's another method you can use, guess and check. But if you really struggle with this, you can always go back to the quadratic formula. The only problem is quadratic formula finds zeros. Okay? And what we want are factors, which are polynomials. So what you would actually be doing now is changing this into an equation, setting it equal to 0. Here's my A, here's my B, here's my C. Using the quadratic formula, it says that x equals the opposite of b, so the opposite of 5 plus or minus b squared. So 5 squared is 25 minus 4 times your a times your c. Take that negative with the 4. All divided by 2 times a. And so as we start simplifying, again, one of the things I do is that I can punch this whole chunk that's under the radical into the parenthesis or into the calculator. Or if I multiply it out, I multiply these three together. So 4 times 4, 16. And so we get a positive 96. And so what I'm looking at is negative 5 plus or minus the square root of 121 all over 12. Square root of 121 is 11. And now I'm going to break it into my two parts. One's where I take negative 5 and add the 11. And the other where I take the negative 5 and subtract the 11. And so when I simplify these down, what I get is 6 over 12, or 1/2, negative 16 over 12, or negative 4/3. Now again, like I mentioned, these are zeros. These are what x equals when I need to set my function equal to 0. So now what I have to do is work backwards and get it into a polynomial. So what I need to do now is change these into something that's equal to 0. Okay, so what I'm going to do here is multiply both sides first by 2, and then I'll be able to subtract 1 from both sides, 2x minus 1, just like I've seen in my first two examples. Same thing here, multiply both sides by 3, okay. Add my 4, and again, whoops, backwards, 3x plus 4. So that's just another method you could use. But the thing is got to remember, if I use quadratic formula, I got to change it back into polynomials. All right, good luck with that.